Every manufacturer in the ultra-class haul truck category makes trucks. Some of them also make excavators. But only one major manufacturer designs both its excavators and its haul trucks with explicit system integration as a primary engineering objective, treating the excavator-truck combination as a single production unit that should be optimized at the system level, not just at the individual machine level. That manufacturer is Hitachi, and the truck that carries its system integration philosophy into the ultra-class haul category is the EH5000. One of the largest diesel-electric haul trucks in the Hitachi lineup, designed to work alongside the EX8000 excavator. In a combined system that delivers productivity greater than either machine could achieve with a non-integrated partner. The Hitachi EH5000 has a payload capacity of approximately 296 metric tons, somewhat below the 363 metric ton class of the Caterpillar 797F. The Liebherr T282C and the Komatsu 980E, but positioned as the optimal match for the EX8000 excavator's loading characteristics. The choice of 296 metric tons rather than 363 is a design decision that reflects the specific EH5000 EX8000 system's loading dynamics and the specific applications Hitachi targets with this combination. But before we get into the engineering of the EH5000, we need to understand why the truck-excavator match matters so much. The way a truck and excavator work together determines system productivity in ways that individual machine specifications cannot predict. An excavator with a given bucket capacity fills a truck with a given payload capacity in a specific number of passes. The number of passes determines how long the truck waits at the loading point. The time the truck waits is non-productive time. Minimizing loading time requires optimizing the number of passes per load. Not too many, but not too few. The EH5000's payload matched to the EX8000's bucket produces a passes per load relationship that Hitachi's system engineers have optimized. Primarily for iron ore and copper operations in Australia and South America, where Hitachi's combined fleet has its strongest market presence. The optimization reflects swing geometry, dump placement accuracy, and the payload distribution across the truck bed. The specific choices about payload target and control system integration produced a combined system productivity that exceeded non-integrated partners. The whole was genuinely greater than the sum of its parts. This system-level advantage is the central element of Hitachi's strategy. The Hitachi EH5000 uses an AC diesel-electric drive system, consistent with the industry standard for ultra-large mining trucks. The diesel engine drives a generator. The generator produces three-phase AC power. AC traction motors at the rear wheels convert electrical power to mechanical torque. The inverter system controls the motors with precision. What distinguishes the EH5000's drive system is Hitachi's specific implementation of the AC drive technology, the specific inverter design and control algorithm. Hitachi is one of the world's largest electrical equipment manufacturers, a company with deep expertise in power electronics and AC drive systems. The drives in bullet trains, industrial robots, and renewable energy installations, Hitachi's engineering knowledge from these applications influenced the EH5000's design. This expertise produces specific advantages. The inverter control algorithm benefits from Hitachi's depth of experience with AC drive optimization across multiple industries. The thermal performance of the inverters reflects manufacturing standards developed for industrial drives that must operate continuously in harsh environments. The traction control system manages individual wheel torque to prevent wheel spin and maintain tractive effort in variable ground conditions. The speed and precision with which the system detects and responds to wheel spin reflects the millisecond response times that Hitachi enables. The dynamic retarding system uses traction motors to generate braking force on downhill hauls without using the service brakes. The retarding force modulation is a key characteristic that operators observe when evaluating performance on the downhill haul portion of the cycle. The EH5000's fleet management integration reflects Hitachi's IT capabilities, another area where the company's breadth of expertise creates advantages. The Wenco telematics system provides operational data transmission, machine health monitoring, and fleet optimization capabilities. Integration between EH5000 and EX8000 data provides the system-level visibility that Hitachi's ecosystem approach aims to deliver. The EH5000 operates weight, when fully loaded, reaches approximately 496,000 kilograms, approximately 496 metric tons. Its empty weight is approximately 200,000 kilograms. The payload fraction, 296 divided by 496, approximately 0.60, is competitive with the best ultra-class trucks. Higher payload fraction means less energy expended moving the truck itself relative to the payload it carries. And in a machine that consumes fuel at mining truck rates, even small improvements in payload fraction compound into significant operating cost differences. The truck's overall dimensions place it in the large but not ultra-large category, shorter and narrower than the 363 metric ton class machines. The tires are the same class of 4-meter ultra-large mining tires used across the category, 6 tires, each costing $40,000 to $50,000. Each tire weighs over 5,000 kilograms. The tire management disciplines that apply to all ultra-large mining trucks apply equally to the EH5000. The structural design of the EH5000 reflects Hitachi's specific engineering choices about the balance between structural stiffness and weight. The frame is fabricated from high-strength steel using Hitachi's specific welding procedures and heat treatment protocols. The structural analysis process, finite element modeling, reflects the same analytical rigor that Hitachi applies to its excavator structural design. The result is a frame that meets fatigue life targets across the range of haul cycle conditions without the weight penalty of an oversized structure. The cab environment reflects Hitachi's attention to operator ergonomics, the same priority that produces high-quality cab environments in the X8000 excavator. Climate-controlled, well-insulated, equipped with a suspension seat, multiple camera feeds, and a clear instrument cluster. The payload monitoring system provides real-time information that allows the operator to confirm correct loading and plan their driving behavior. The maintenance access reflects the same serviceability philosophy that characterizes Hitachi's design. Service points located for accessibility. In remote mining environments where the EH5000 is deployed, the ability to perform maintenance correctly in the field is essential. Without the workshop infrastructure of a centralized facility, maintaining availability makes the machine economically viable. The Hitachi EH5000's strongest commercial position is in operations that also deploy Hitachi excavators, primarily the X8000 and its predecessor models. In these operations, the system integration advantages that Hitachi's ecosystem approach provides are fully accessible. The fleet management integration between excavators and trucks allows for real-time data sharing and maximum operational efficiency. The service network covers both machine types with common technician training and parts supply chains, ensuring minimized downtime. Operator training programs cover both excavators and trucks within a single curriculum, streamlining the workforce development process. Hitachi's mining equipment division provides combined field support for complete fleet deployments across the globe. In Australia, Hitachi's strongest mining market outside Japan, the EH5000 has established a significant fleet presence in iron ore and coal operations. The Pilbara iron ore producers have deployed EH5000 and EX8000 combinations in high-intensity operating configurations. Detailed performance data confirms the system integration productivity advantages that Hitachi's design philosophy targets. The copper mines of South America represent another important market for the EH5000 ecosystem. The high-altitude conditions and hard porphyry rock demand robust structural performance from both excavators and trucks. Production scales in these Andean operations justify complete ecosystem fleet deployments where EH5000 strengths are fully expressed. Across different continents and ore types, there is a consistent pattern of ecosystem benefit. Operations report system productivity metrics that exceed those achieved by comparable mixed-brand fleets. The integration advantage is real, measurable, and accumulates over the operating life of the fleet. It creates a total cost of ownership advantage that makes the system-level investment argument compelling. The Hitachi EH5000's development trajectory follows industry trends: autonomous operation, electrification, and continued digital integration. Hitachi's specific advantages in information technology and power electronics position it well for all three development directions. Autonomous haulage, trucks operating without onboard operators, is being developed by Hitachi in collaboration with mining operators investing in the technology. The integration between autonomous trucks and excavators is a specific focus of Hitachi's research, reflecting an ecosystem philosophy. When both machines are under coordinated control, loading interaction can be optimized with precision not achievable by human operators. Electrification, the transition to battery electric or trolley-assisted operation, will be facilitated by Hitachi's power electronics expertise. The traction motors and inverters already present in the diesel-electric drive require no modification for battery or trolley power operation. The generator and diesel engine are replaced by the new energy source. Hitachi's experience with battery systems provides the necessary engineering knowledge. The timeline for EH5000 electrification will follow the industry's trajectory, driven by battery maturity and mine operator demand. The Hitachi EH5000 is not the largest or most powerful truck in the world. It does not hold the payload record. What it is, the most completely integrated component of a mining equipment ecosystem, is a different kind of achievement. This is measured in system performance, tons per hour from a complete production fleet, and cost per ton across an operating year. That is the achievement the EH5000 was designed to deliver, justifying every engineering decision that went into building it. Next, we move from the truck that carries material to the excavator that digs it, specifically the mid-range Caterpillar 6020B. The 6020B serves a broad range of applications with capability and flexibility that larger machines cannot match.